Whereas section 3 was about segments, section 4 is about angles. Alright, and I'm not going to go into what an acute angle, what a right angle, what an obtuse angle, or what a straight angle are. I'm assuming you know that. If you don't, look it up. You got a textbook. So we're not going to talk about that. What I am going to talk about is some notation. So an angle looks like this. It's made up of two rays. I'll call this angle A, B, C. Okay, and we can name this in three ways. We can name it angle ABC, like I just said. We can go the other way. We can call it angle CBA. Or we can just call it angle B. Whenever possible, we'll just call it angle B. But we run into trouble when there's another side off here. How do we know what angle B is? Is it this? Is it this? Is it maybe the whole thing? We don't know. So we can't just do that. Okay, but we can name this angle in three sides. In three ways, rather. This is called the vertex of the angle. The plural of vertex is vertices, not vertexes. I'll subtract points from your grade if you say vertexes. Okay? And then ray BA and ray BC, both of these, are sides. Like I just said, they're rays. The sides of an angle are rays. So BA and BC are the sides. Point B is the vertex of this angle. Okay, I'm assuming that you know that angles are measured in degrees. I'm not going to talk about that very much. Just like for segments, if I say the measure of angle D is equal to the measure of angle F, and that's how you'll see that written. M angle symbol as the angle symbol, which you probably figured out from about 20 seconds ago. If I say these angles have the same measure, that means that angle D is congruent to angle F. Again, these are numbers. The measures are numbers. They're measured in degrees. These are actual figures. Figures are congruent. Numbers are equal. So it's very similar to what we talked about with our segments earlier. So keep that in mind as you're doing this section. Another quick thing. If I have this angle, this point, and this point, all of these points are in the interior. This point, this point, this point, this point, this point. All of these points are in the exterior. Those two things mean exactly what you would expect those to mean. Now, not every point is interior, exterior. I can have points on the angle that are neither place. Okay. Next, we get something that should sound sort of familiar. We're going to get the angle addition postulate, which we will abbreviate AAP as we move forward. Angle addition postulate. And this basically says we have two angles that are adjacent. Now, what does that mean, adjacent? Adjacent angles means they share a common side, like this, and they don't overlap. So adjacent means they have a common side, and it technically says they share no common interior points. That basically means they don't overlap. Okay, so anyway, the angle addition postulate says if we have two angles, sometimes you'll see, well, we'll do it this way: A, B, C, and D. If we have two non-overlapping angles, two adjacent angles, the measure of angle ABC plus the measure of angle CBD equals the whole thing. The two parts equal the whole thing, the measure of angle ABD. That's the angle addition postulate. It's the very same exact idea as the segment addition postulate. Now, what I started to say a second ago is sometimes you'll see a little number inside the angles. So it's actually another way we could name these. We could call this angle 1. We could call this angle 2. So you'll probably see that here and there. Don't let that upset you or confuse you. It's just another way we have of identifying angles. Sometimes it's easier to do it that way.